Hello again. I'm Anderson Smith, and today we're going to talk about vision, seeing, ability to detect things in the environment because of light. And as we mentioned in the last video, vision actually transforms light energy, photons, into neural energy and action potential. And it does it in the sensory organ, which is our eye. I have here a drawing of what the eye looks like in the parts of the eye. You can see that light, in this case, a green leaf. Notice that image has borders, it has color, and it might have motion. I might be looking at the leaf as it's falling from the tree. So light energy has several dimensions to it. And it first goes through the cornea, the front of the eye, which protects the eye. It's clear. And by the way, it has lots of pain receptors. When I was a teenager, I was a lifeguard, and as I was rescuing someone, she stuck her finger in my eye with a fairly long fingernail, and it caused a lot of bleeding, and I've never had pain like that. So there are a lot of pain receptors located in the cornea of the eye. Then it goes through the lens, and it's really through the pupil that sort of decides how much light is going to get in on a bright day. The pupil will be restricted, and at night it'll increase and allow more light to enter the eye. Then it goes through the lens, which is a part of the eye which can be stretched and constricted, thus focusing what I'm looking at on the back of the eye, where the retina is located and the sense organs are located. Let's look a little bit at just one part of the retina. And what you can see from this drawing is that the light coming in from the eye actually has to travel through all of the neural cells to get to the rods and cones, which are the receptors located in the very back layer of the eye, the retina. So the rods and cones of the eye detect light, and then they turn through transduction, turn that light energy into action potentials. It goes to the bipolar cells, and then it goes to the ganglion cells that gather together and leave the eye in the optic nerve. Now, the interesting thing, we'll talk about this next time when we talk about receptive fields. The interesting thing is that as they go from receptors, rods and cones, to bipolar cells, to ganglion cells, to the thalamus, and then to the cortex, information processing is occurring at all those points. So in one sense, when you talk about sensory receptors, you're talking about an extension of the brain, because by the time it gets to the cortex of the brain, a lot of information processing has already occurred at the synapses between those cells. As the optic nerve leaves the eye, there are no rods and cones. So we can actually demonstrate, and it does in the OLI material, you can demonstrate the blind spot where the optic nerve leaves the eye, because you just can't see something that's located and focused on the blind spot. Now, the fovea, which is directly the center part of the eye, right in the back, when I stare at something, I'm really focusing that object on the fovea, contains mostly cones. And cones are used for day vision, and they perceive color, and they're very, very sensitive to fine detail. The rods, which are primarily located outside of the fovea, require only low levels of intensity light, and they see black and white. But they see it at low levels of illumination. For example, in the rods and cones, this chart shows where they're located. So there's the fovea, and then we go away from the fovea into the periphery, and you can see the cones are located right here in the fovea, but the rods are located in the periphery outside of the fovea. So if you want to stare at something at night, you don't want to focus it on the fovea, you want to focus it just outside the fovea, and you'll be able to see it better. So we talked about the rods and cones. They're connected to the bipolar cells and then to the ganglion cells, all located in the retina of the eye itself. And as I mentioned, a lot of processing goes on in those synaptic connections before it leaves in the optic nerve that then goes to the thalamus, where again, a lot of information processing occurs, and then it goes to the visual cortex or the occipital cortex in the back of the cortical areas of the brain. So that's vision, and that's how information that we can see is taken to the brain to be perceived and interpreted. Thank you.